Hey,
Here we go.
welcome one and all, everybody, to Santa Barbara Astronomical Unit's weekly YouTube vlog that we call the SBAU Astro Hour. I'm your host, Ronnie Heron, for a while, opening anyway, and my friends on the screen, there's 5 of us from the club, take us deep into the cosmos every week with cutting-edge astrophysics. And we're now Monday mornings, 5.5 years of this. It'll soon be, in fact, it's our 286th program. And we're finishing our 6th year. SBAU is based at the Santa Barbara Museum of Natural History. And doggone it, where's a better place to hold astronomy? First Friday general meetings every month, complete with science speakers. And we follow a week later with our monthly second Saturday star parties outside in the dark, complete with telescopes. And we even convene there on Sundays to watch the sun. Next general meeting, incidentally, is in 3 weeks, September 4th. It's all about quantum physics and the outreach. We're everywhere, let me tell you. Here's what we're talking about this week, everybody. Just a matter of time before we start naming bursts of glowing plasma from the surfaces of the sun. There was a big one back in May. We're calling the Godzilla prominence. We got a complete recap of last week's solar eclipse that traveled down through Europe. What's up with Comet 10P Temple 2? Well, it is up. And you're going to have to stay up and outside. We'll tell you where to watch and look. There's another comet. It's green. Photobomb the sun as it reached the perihelion closest pass, very bright. Time for a binary variable star that's a recurring nova, T Coronae Borealis. And we're going to get very serious. In fact, Sirius Iridium, one of our moon's most beautiful distinctive features, the Bay of Rainbows. Spica, the brightest star in Virgo, is a special B1V. Even your most best friends won't tell you if you're a B1V. Also, a couple of orbiting stellar masses. Let's meet the gang on the screen around me, including the man that becomes an incredible lecturer, our president for 10 years going on, Jerry Wilson. Good morning.
Good morning, everybody. Good morning to my sister Joyce and my grandkids Calvin and Riley.
And Pat.
And my wife, Pat.
She is the first lady. She's healing and doing well. And like she's over beside you off the picture inside the peanut gallery with all those people you just mentioned.
Yeah.
Well, you did a great job a couple of weeks ago. We're still great to have you as a lecturer. SBAU's incredible outreacher. He's everywhere. One-man show with his agent pet rock, Chuck McPartland, who's also married to a Pat. Pat is our, she's our treasurer, best one we've ever had. And I guess going away, what is it? Merch manager. What does that mean? It's about sold out. We got this small size jerseys left.
Just small size clothing, but there's still mugs and bags.
Well, I'll give away the mugs every time. Hey, look here. A future Cosmos speaker joined us, really knows his lenses, Tim Crawford.
Hey.
Who's married to Karen. Our club's longtime newsletter editor, retired professor of science at Westmont, and a birder and a bread maker, Tom Whittemore.
Morning.
Good to see you. His wife is Maureen.
Yeah.
We do every week. I don't know how we run out. There's a non-supply, an endless, a non-ending supply of silly stuff. Maybe we used up all the Gary Larson Far Side, but we still got Bizarro and cartoons. These are the silly science things that were sent to us by the press, who's going to guide us through. Oh my God. Here we go. Jerry, what are we looking at? An ancient tribe?
Yeah, these are people living in their grass hut in a village. And this canoe pulls up, and 2 scientists in field gear come out. And one of them sees them and he starts yelling, anthropologist, anthropologist. So they're quickly hiding all their modern conveniences, the VCR. And
That's what it is. I just didn't understand it.
Now yeah. As typical Larson.
Yeah, that's Gary Larson's Far Side, isn't it?
Yeah.
Amazing stuff.
Right there, Larson.
Well, I imagine there's some factual, whose cat is this? Chuck, you want to guide us through what we're watching here?
Okay, there's a picture of a cat. looking unhappy with the vegetables on the dish. And he's saying, I was told I could use a colander to watch a solar eclipse, and I tried and I just strained my eyes.
Yeah,
That, folks, is a pun.
Yes.
that's right.
Is there something to that? Does a colander make a million little things on the wall?
Yeah,
Yeah.
yeah, it's a
Each,
strainer.
each hole acts as its own pinhole camera.
I'll be damned. Okay. Who wants the guy you're gonna have to break? Can we read this? Can you guys read it?
Yeah, I can.
All right, then you tell us what we're looking at. A couple of dogs on the moon. Like
Okay.
them talking, looking up and saying what?
It really makes you realize how small and insignificant we all are, except Master, of course.
That's true here, right? Okay. Anybody want to talk about history? And Jerry, tell us what this is.
This is a brief clip on the history of physics. Aristotle said a bunch of stuff that was wrong. Galileo and Newton fixed things up. Then Einstein broke everything again. Now we basically got it all worked out, except for small stuff, big stuff, hot stuff, cold stuff, fast stuff, heavy stuff, dark stuff, turbulence, and the concept of time.
Very good.
And the march goes on.
Where in the world did you get that?
Just happen on it.
It is okay. Were you a Star Trek fan, Tom Whittemore?
Sure. From this point forward, alcohol will be banned, but weed will still be allowed. So you're just going to leave us high and dry?
Jean-Luc Picard. What was his name? Does anybody remember? Captain what?
Jean-Luc
Picard.
Picard?
Jean-Luc
Yeah,
Picard.
Jean-Luc Picard.
That's all we know is his name. Okay.
Well, that was his name on the show.
Mhm.
Yeah. That was the character's name.
It's
Mhm.
Patrick Stewart as the actor.
Right.
Yeah.
I'm sorry. I thought that was his real name. You want to get us through here, Mr. Outreacher?
Okay, two astronauts up on the International Space Station, and one's got an IBM laptop and one's got a Mac, and one says to the other, here, take the MacBook, you shouldn't use your PC. And the other one says, why not? And he says, because you can't open Windows in space.
Okay.
Well, as you can tell, I happened upon a website of puns.
Yeah, I was going to say a lot of puns today.
Yeah.
I'm curious,
Good, Jerry.
I'm curious about your laptops. Do they get hotter when we're on the air? Mine is hot as hell. Sitting
Yeah,
on
it's
my
doing a
lap.
lot more processing for the video.
I guess it does. It's never been this hot. I'll let it vent. Okay, let's get the night sky and get going here. Today's 286th program.
Can you see this?
Not yet.
17th.
Not yet.
This is
Okay.
for August 17th to the 23rd. It's coming, folks.
It's
They
coming.
even have a curved horizon, concave. No, it's the sun's horizon.
What's that?
It's the sun's horizon, right?
Oh, yes. So you see this.
Yes.
That's the prominence
yes,
we
indeed.
know.
Okay.
The video is incredible, Jerry.
Yeah, there's a fellow that has taken a couple of short videos. This is a scene from one of them. He does very good processing on the solar image. And as you can tell, these prominences and all this stuff are not just flames coming off a campfire. These are pieces of plasma that are following magnetic field lines. This is all magnetic field determined. And when things get aligned, they cool off and they become visible. And when they're too hot, they're invisible. So just like sunspots, but looking at them from the side a little bit.
Now, correct me if I'm wrong, but flames are plasma anyway, aren't they?
Yes, they are.
Yeah.
Yes.
Well, are we seeing two or are those two connected?
What's that?
I'm seeing two or are they connected somehow?
These are all part of one complex.
Oh,
You can
okay.
see the filaments in here and going up here, and then there's nodules of very bright stuff where there's a lot of material in here.
I didn't realize, Jerry, that when they cool is when they become visible. I didn't realize that.
When they cool?
Yeah,
It
in other
happens-
words, you can see the arch, you can see an arc there,
Yeah.
right there that Jerry's highlighting,
Yeah.
and that's not really visible because it's too hot, I guess.
Yeah. And what you see when you get something like this, if you look at it close up, this material is all falling back.
Well, tell me this, does the whole thing happen within hours, minutes, or days? Is it suspended?
These things change shape over, say, 15 minutes to an hour or more. Sometimes they last pretty much all day long. Sometimes they, you go, come over here and look, and they come over and it's all changed.
You know,
There's no
prominence,
rule.
the prominences, Ronnie, they can last 1 or 2 days.
So
But
do you guys on Sunday see any movement?
Not really, but we do
No.
over a period of time, though, you can come back and they will change
Yeah.
appearance.
Yeah, yeah. You can see them over the course of an hour or so change. Or when we start up around 2, by the time 4 is, things we noticed at 2 might have a little bit different structure.
But what we just saw, Mr. President, it happened in May. Was it on a Sunday? Were you guys out looking? Did you see
No,
this?
this was, I think, the 24th, or this was several weeks earlier that the guy saw this.
I
Okay.
thought you said May. I swear
May,
I
yeah.
saw
Mhm.
something happened in May. Okay. But if it happens on a Sunday, you guys can photograph it, right? And bring in the picture or
Yeah, actually, yesterday, Tim had a visitor at his telescope take a picture of the sun.
We had I have a couple of different little gizmos to attach your phone to a camera lens or to a lens to an eyepiece,
Eyepiece.
and
yeah.
they work quite well, but you have to set them up. It takes a while to set them up. This guy just handheld his iPhone
Right,
or
right.
his video his phone, and I was amazed that he got a pretty good image that wasn't overexposed. Usually they're way overexposed,
Mhm.
but he did say, as I've always commented on, is that an older camera is really nice because it has a single lens. And when you get all these cameras, it's got about 12 different 12 different lenses on the back. What ends up happening is you're just about ready to take a picture and one lens will switch to another one.
Yeah.
It's very annoying.
well, forgive the gravity of this question, but if a normal person were to look at the sun through a lens that isn't filtered, what would happen? Would he lose his eye?
Yep,
He would, huh?
instantly.
And it
Can you-
really.
Can you guys see this share?
Yeah, oh,
Yeah.
yeah, that's
Okay.
beautiful.
Oh, here we go. This is the video.
Mhm.
Nice.
And that's filtered.
Yeah, look at the
Oh yeah,
plasma.
this is really good. This is really good, Ronnie.
Yeah, so that's detached and then it's falling back onto the sun's surface.
Yeah.
And you
And you
guys
can see
didn't.
that arc.
Yeah, every now and then, Ron, we'll see a detached prominence.
Well, now we're seeing it on the edge of the sun.
Mhm.
What if it were in the middle of the sun? It'd be coming up toward us and we wouldn't see a thing, would we?
No, you see filaments.
Yeah,
We
filament.
would?
Yeah, they appear to be either a squiggly black line or else grayish. And you can in really good scopes, you can see this grayish cloud kind of floating above the surface.
And they're not connected to the sunspots?
Yeah, they often are.
Well,
Yeah,
they sometimes come out of.
where sunspots clump together and go through the surface, then you see the spot. This is a picture I took.
Mhm.
I just put it in there since I happened upon it on my computer in May of 2012 from Utah, where I was going to see the annular eclipse.
Mhm.
These extra rings are internal reflections in the camera, which was a Canon DSLR. You can see the prominences around here. And these were just quick snapshots. But the real thing that I started with was we had a eclipse, which was a total eclipse, a few days before this, last week, I think on Wednesday. And we covered that a little bit before the eclipse, but I couldn't get any photographs of the eclipse before it happened.
Hmm.
So I waited and we got a few action shots from that. This shows the Earth and it shows the total eclipse path
Yeah.
going around through here through Greenland Iceland, and then down across through Spain.
Yeah, it started out in Siberia, Jerry.
What's that?
It started out way up in Siberia.
Yes, way
Yeah.
up here. Yeah.
Mhm.
Well, I'm sorry, gentlemen, I have trouble imagining where the hell the moon was to make that track. Why wouldn't it go across the earth? Doesn't it kind of?
That's what it's doing. The Earth is a globe.
I know, but I think don't we have an equatorial plane that it's pretty much on?
No,
Mhm.
Not on the equatorial plane at all.
nope. The earth is tilted and the plane is tilted.
Yeah.
Everything's got to have a tilt.
No, Ronnie's right. The Earth is flat.
Well,
Okay,
imagine,
moving right along. This
Yeah.
guy took a picture of the space station, the
That was really neat.
Yeah,
and
that's
then
something
I
else.
think this was taken from Maine.
That sounds right, Jerry. I remember seeing it live TV.
That's
Yeah.
what the caption at the top says, partial from Maine.
Yeah.
Okay,
well,
so
imagine
it was a well-covered event.
our professor at City College, when he gets back from Spain, is going to have some great pictures.
Yes, yes. Now this
Oh,
shows
yeah.
the inner corona. It's and it's actually a fairly calm corona. You know, it's sort of uniform around here. We'll see a better picture of it going farther out.
Mhm.
But there's so many grades of brightness that you can take 5 or 6 different settings, exposure times and ASA numbers or ISO numbers nowadays. And you can get whole different representations of the sun because there's so many brightness gradients in this. This is a nice picture, photobomb. Obviously, the sun is very low on the horizon.
Mhm.
That's the recent one.
Wow.
Yeah, this was
you
last
might want to
Wednesday.
mention that this was a sunset eclipse for most people.
Yeah.
And the last picture showed, you know, how close you got to the horizon setting.
Yep.
And they're not up in Greenland or Iceland or anywhere. Everybody's wearing shorts.
Yeah.
Well, PBS ran a program the other day about it, and apparently they could see stars.
Yeah.
Oh,
Of
yeah.
course.
Mhm.
Really?
I really like this one, Jerry.
This is a picture just before or just after, depending on whether it's starting or ending, what's called the diamond ring effect. You see a faint ring around here. You can see a very prominence right there.
Oh, that's an
And this
amazing
is the
problem.
these are the last set of light rays. These are shining down the valleys on the edge of the moon to get to us. So, and then when the limb of the sun finally comes out or at last disappears, you get this overwhelming brightness, which makes it look like a diamond ring.
Yeah.
You know, this on I think it was CNN. Somebody asked the question, what is Bailey's beads? Is
Mhm.
that part of the
Yes, that's
the
it.
diamond ring?
Sometimes see this red ring around here?
Yes.
You can see there are little dark patches in it.
Those are Bailey's
See?
beads.
Yeah.
And it looks like beads along here. Those are Bailey's beads.
Okay.
And
Here
they can
it's-
be really bright. It can be like a diamond ring with multiple studded diamonds on it.
Yes, yes,
Okay.
exactly.
Yeah. And those are
So
from
this is
the
shiny.
craters, Tim.
What's
The,
that?
the uneven surface of the moon produces
Right.
those things.
Oh, okay. Okay.
Where it's bright here, you're seeing light going down a lunar valley.
Mm.
Where it's dark here, you're seeing a lunar hill blocked that light.
There we go. That's what it is. Nice. Now I understand. That was a really good question somebody had.
Yes, it was.
Wow.
This is a very long exposure because these are very faint things. It shows the extent of the corona,
Wow.
and there's a lot of structure to it. So it's not just a uniform thing as the first picture implied. And you can see a lot of stars around here.
Oh,
The for what is it in 1917 when they looked to test Isaac Newton or not Isaac Newton,
Einstein.
Einstein's
Mhm.
general relativity, they were looking for stars in this region around here.
Yeah. I think it's
Very close,
1919.
within a stellar diameter.
gravitational lensing.
This picture reminds me, my neighbor across the street, his daughter was somewhere in Spain. I didn't get the city, but she was holding her iPhone. And of course, the sun was even smaller than this, but it was one of the clearest and clearest views of the eclipse that I saw.
Yeah.
And I was amazed. I couldn't share it because she was using some good expletives. She was really amazed by it. So
Oh,
Now
this is
this-
washed out.
was
It's really bright.
Yeah.
Yep. Okay. So this is the dark bands. And let me just get out of there and out of there.
Oh, the bands. This is another one that I think a few years ago somebody was talking about ripples going across the surface.
Yeah.
Yeah. I have a video that shows it better.
I've never understood this one either, Jerry.
I'm not sure. What are we looking at?
Nothing
Well,
yet.
we're going to get a different view of it.
It looks like the Earth.
It is.
Oh,
These
okay.
are called shadow bands.
Oh, I see. Okay. Hmm. Definitely some square plots on the lower left.
Uh-oh. This could be a uh-oh.
Are we about to lose our
No,
leader?
possibly. I just got to get
we
the
lost
right.
Jerry.
Yeah, Jerry's lost.
Oh, you can't see me?
Well, you're frozen.
You're
Oh.
frozen and the screen's frozen. I think you closed the app while you were sharing the view,
Okay.
and somehow that killed it.
Yeah. Okay. Well, what I can do then.
Okay, Captain Picard, beam us up quick.
So, Chuck, what do you have to do? Do you have to stop sharing first and then close it?
Looks that way.
Oh, okay.
Was this going to show us the track on the Northern Europe?
No, this is shadow bands. This is you look down at the ground during the beginning phases of the eclipse, and you
Oh, I
see these
see, the
alternating
darkness.
bands of shadows going across.
Got it.
And I don't think there's a good explanation for them. It might be, packets of air at different density in our upper atmosphere as the wind blows them across doing that. But I don't know that there's a good explanation for them.
Well, that sounds as good as anything that I've heard. I don't know what it is, and I know Tom when Tom was talking about the valleys and mountains of the moon causing the Bailey's beads. That's another good thing that I'd forgotten completely about. I have an old image of a solar eclipse, and I thought, well, this didn't come out real good. And I think Tom saw it, and he goes, "Jim, are you kidding me? Those are the craters. It looks really good."
But even though the solar eclipse gets covered by the moon, there's always that corona. So you got some left. The corona is supposed to be one of the hotter parts of the sun.
Yes.
It's 10 million degrees. And so you're always at that diamond ring, aren't you?
No.
It's not going to just go black.
No, you don't have the diamond ring. The diamond ring effect is only when the photosphere of the sun is showing through a valley on the moon.
Yeah.
And it's not a complete center moon eclipse.
It could
Slightly
be.
off.
I mean, you've got these valleys.
Well, I mean, what did they see in the lighter bands that we were about to look at on that map there that he's trying to fix up? On
It's
the
not a
edge,
map, it's a picture of the ground.
Yeah, with a map showing where the track was going to be. And in the center, it's darkest. And on the edges, it
Oh,
gets
that you mean the
light.
very first image that he showed with the
Well, when he
globe.
was trying to, when we, yeah, that just aborted
Oh no, that was a picture of the ground.
of just the ground of the earth.
Yes. It's a
Well, George,
courtyard somewhere in probably Spain, and somebody took a video of the ground as these shadow bands went across.
And somebody that had gone to a solar eclipse, Ronnie, they were saying they were looking around on the ground just as the eclipse started, and you could see
Can
all
you
these
see me?
like waves going across the surface of the ground.
Yeah.
Can
Those
you
are the
hear
shadow
me?
bands.
Yes, we can, Jerry.
But we
Okay.
can't see you though.
Oh,
That's
that'll come.
okay. You know me.
The shadow knows.
But it probably means I'm not going to be able to show you I'm not going to be able to share.
Well, you do a great job regardless, Jerry, every week.
It
Put
says you're in charge, so
But all the rest
might
of the
work.
pictures We can't see any of the rest of the photos that came with the talking point?
No, we can get those.
Yeah.
Think so? Okay.
Yeah. Just changing from one back and forth is really hard.
Good old
Yeah, the
Zoom.
machine locked up.
Mm.
Never a dull moment with Zoom.
No. So we'll pass on that one.
Yes.
Well, it looks like we're going to pass on everything if you're in control, Jerry.
Well, we'll see.
Well,
He's got it, Ronnie. He's got it.
it's going to be us four ugly old men talking to each other on the screen.
Well, I might be able to play it and share it.
Yeah.
Let me see if I can play it.
In other words, just scroll down his talking points. Oh, there we go.
Oh,
I think I'm sharing. Can you see it?
Yes.
Okay.
That's got to be the comet.
Yeah, this is the comet Temple 2. This is a short period comet. You see, it doesn't even get out to Jupiter. It crosses the ecliptic out here at the maximum distance. And right now, here's Earth and here's our comet away from the sun. So it's a good position to look at it. These are pictures, a collage of pictures over the last few months. They are dated. Up here, it's, oops.
it's in the lower left of each image.
Okay. Yeah, this is July 18, 2026. This is June 18, June 25.
No, they're July. 7 is July.
6, right. Yeah,
6 is
6.
June,
Okay,
yeah.
good. Okay. As long as you get the basics right, the details take care of themselves. Yeah.
But you can really see that trail coming out on either side on the last one.
Yes. That's a trail that you're looking down the plane of the orbit, and someday that will be a meteor shower.
Oh.
If we pass through it.
Yes, if we pass through it, when we pass through it.
When we pass through it, because this is the parent body of.
Yeah.
Well, how often are comets green?
This is a
Very
very
often.
well processed image. You can see faint traces of nebulosity in the background, dark nebula. That's very difficult to bring out unless you're an expert processor. This is the comet in here, and you can see the fan-shaped tail going out behind it because it's pointing at us and then the sun. So it's in opposition to the sun. So the tail is blowing away from us.
But it is up there in the night sky above us, right? Every night?
Yeah.
Then why can't we aim one of our telescopes at the star party at it and get what we're just seeing here?
Can,
This
if you
is
want to
coming up
take the
late.
time.
It's too late? Is that what it is? Okay.
This is a finder chart for where it is. This is Capricornus here. This is the comet, and these are different. I thought these were dates, but they're obviously not.
Yeah, 27.3 p.m. is kind of weird.
Yeah.
Oh, it's days and hours. Okay. So that's the 27th.
Oh, I see. Yeah, you're right. Well, then what's this? Oh, this is the next month, the 5th, September
Yeah.
5.
Yep. You got it.
Okay. See, this information looks different at midnight than during the light of day. And this is Fomolo down here, so this is quite far south for us. You need a very good southern horizon to be able to see this.
Gonna take a sudden turn there at the bottom.
Yeah. Now this is a different comet.
Well, that's kind
This
of
is
affected
also in
both
the-
it and our orbit, Ronnie.
Ah, okay, got it.
This is McNaught, taken August 8th. The green comet, it's called. And this is a chemical that breaks down, and by the time you get farther away, that green chemical is gone.
It's not a
Now,
certain element
this
like,
is a
like
It is.
oxygen?
Well, it's a carbon compound. It's a diatomic carbon.
What did you say oxygen shows itself as color-wise?
It fluoresces green also.
Oh, okay. That's what I thought.
Okay. This is a photograph of Comet McNaught. Right.
Totally washed out.
I didn't want to say anything.
Yeah.
Looked like a street lamp to me. I'm sorry.
Yeah.
Okay. Okay.
Boy, do I get that question about aliens a lot at star parties now. Holy mackerel.
Just tell them you are one. Take
No, I
me
just,
for-
Okay.
There it
oh
is.
yeah, yeah,
There
by
it
God,
is,
there it
yeah.
is.
This is Comet McNaught about um, at least 10 years ago.
Mhm.
Took it from my bedroom balcony out over the Pacific Ocean down here,
Mhm.
and your friendly street light in the way. But this was just with a handheld camera, a cell phone.
Oh,
So McNaught has been around.
You know, Jerry, some of the newer phones now,
Yeah,
you can highlight the street lamp and it'll disappear.
yeah.
That's kind of cool. I don't know how they do that, but
It is if you can control it, but it has a mind of its own.
yeah,
And the light that it has sent through the rest of the picture is still there.
Yeah.
yeah. Probably pretty soon they'll have one. You highlight the street lamp and the phone disappears.
Yeah.
Well, you may remember several years ago, a couple of years ago,
Yep.
there was a lot of hoo-ha about T. corona borealis,
Mhm.
and it is a repetitive nova. It's located here in this red circle in the sky. This is Hercules. This is Corona Borealis and the coronet. And oops, oh, there it is. This is the one that goes through periodic eruptions. And so far, it's done it in 1947 or 46, right here. This was the last time it erupted. And it goes off roughly every 80 years. And it shows this pre-eruption dip before it goes off. So it goes down there, then it comes back up, and then it cruises along for a while. Then all of a sudden, whoops, someone hit the button
Mhm.
and it went off. So we have passed through this region. We're apparently approaching this thing, and we'll see some predictions in a moment here. Okay, I misnumbered these things. So, oh, this one doesn't keep track of the numbers anyway. So I'm going to go back to the other.
Okay.
it went from the moon to the sun and back.
Yeah.
We kind of
Oh,
missed
that's right. I didn't make a slide out of it. It's written out in the talking points. So let me find that.
we certainly miss your professorial visage on screen, Jerry.
You what?
We miss your gray hairs everywhere on screen.
Yeah, that's okay. Okay,
You could share the text, view.
that's what I'm doing.
Okay.
So here, just checking in on T. corona borealis,
Mhm.
call your attention down here to predictions of the next nova in order of when the prediction was made. So this one, and you see several of them are lapsed. That is, we've passed them and they didn't happen.
Right.
So someone said it was going to go between 26 and 27, and this was made in 1946. And so we're okay with this one. It still might be true. Mid-February 2024 to the end of September 2026, made in March 2023. So we got one more month to go on this prediction. Beginning January 24 to mid-August 2024, made in June 2023. This one has definitely lapsed. And then in January 2024, they said it's going to go in August 2023.
Well, no, the opposite way. They
Yeah.
said it would happen in 24.
Oh, in January. Yeah, you're right. January 2024, but the prediction was made in 2023. And this one is definitely
Yeah.
end of October 2024 And that prediction was made in June 2024. So this one, the last one, around March 27 to 2025, that one lapsed. November 10, 2025 lapsed. June 25, 2026 lapsed. February 8, 2027, plus or minus 8 days, made in October 2024. That one has not lapsed. So we have 1, 2, very vague here, and 3 that have not lapsed. So let's see.
You think that guy would have learned after making precise date presentations to say plus or minus 800 days?
Yeah, that's what I think. 800 days. No, I like Tom Totten's.
Yeah. I was just going to mention.
After midnight.
Yeah, probably Christmas Eve at midnight or after midnight.
No, it'll be well, T. Corona Borealis is blocked by the sun from our point of view.
Yes, yeah.
I looked at it the other night, Chuck. I was looking up there, and I think it's Alphecca. That one was very noticeable, but approximate location, I said it's somewhere right about here, and the question was, well, how bright would it get? And
about as bright as Alphecca.
Okay.
So not real bright.
Okay.
And it only lasts like 2 days.
Yeah.
So it's a variable, but it's not a Cepheid.
It's a recurrent nova.
Right.
Well, what's a Cepheid?
A Cepheid is a variable star.
Yeah.
But this isn't one of those.
Well, it is, but it's also a recurrent nova.
Yeah.
But it's not a Cepheid.
Cepheids don't do the recurrent thing?
They don't do nova. The Cepheid is a single star that is
it's
pulsating
continually
in
oscillating.
size.
And
this is a pair of stars, and one of them is sucking material off the other.
Right.
And it detonates.
Yeah, and I noticed that on the chart that we don't have right now, the change in magnitude was 7 orders of magnitude. So 5 orders of magnitude is 100 times, and 2 more would probably make it 400, something like that.
Yeah.
Oh, there it is. So it goes from about 10 to 3. So that's 7 orders.
And I think I've heard magnitude 2, so it might be 8 orders.
Okay.
We will see.
And because it's a binary system with a white dwarf orbiting a red giant, they have some idea of the mass.
Yeah.
The white dwarf is at 1.35 solar masses.
Okay.
And each time this happens, it accretes some mass. And if it goes to 1.4, then it becomes a type 1a supernova. So it could be pretty spectacular at some point.
Oh.
That's a lot of mass, though.
Yeah.
Well, can I ask a question about what we're looking at here?
Yeah.
If the blue track is the brightness range, why are there a bunch of dots? What do the dots stand for?
Measurements that people took.
Yeah, there's data.
This dot right here, it was taken in mid-February 1947. Some guy looked through his telescope and said, this is 9.3 magnitude. And so that dot got there.
Okay, so they weren't all exactly on the same.
No, this is a scattered sky conditions are different for different observers. Their equipment is different. Their eyeballs are different. A lot of these are in the period where it's all visual. Amateurs and even professionals were not using photometry, calibrated photometry at that time in general. Some people had it, but most people didn't.
This is a bad time to ask this. The calibrated photometry, Jerry, is that pretty complex?
No, you just get a planetarium program, and you give it a picture, and it'll estimate how big that or what it'll compare it to other stars around, and it'll tell you how bright it is. It'll give it a magnitude.
Okay.
Join the AAVSO, and they give complete instructions on how to do it and report it. It's very simple.
Okay.
Yeah, you compare what the planetarium program tells you the brightness should be with the number you get for the brightness from your camera, which won't be in visual magnitude usually.
Yeah.
And then you calibrate it to that. And you might have to do it for several stars to get an idea, because it also depends on the color of the star you're observing and the color response of your photometer.
Right. And there are different color magnitudes, a magnitude in one color and a magnitude in another color. So, and you must, if you do this with photometry, you have to be sure you're not saturating your camera.
Okay.
So
that spike in the middle at the end of 1945 going into 46, the year I was born, that suddenly flared up, right? And became
right here, it was normal. Right here, it was still within the range of normal because it was about this level. And right here is where it went from there to there. Well, there's one that caught on the way up.
Yeah. And
So
and you
this-
can tell people got a lot more interested in it by the thickness of the curve after the event.
Yeah. This is where the phone is ringing and say, it's where? You saw what? And then everybody's on it.
and you don't need a telescope to see it when it hits that peak.
Not there, no.
Right.
Wow. So it's
And our
moving-
limit is what? Our limit of visibility is between 5 and 6 magnitude.
Yeah,
Around here, yeah.
under good skies, yeah. Dark
Okay.
nights.
And maybe I missed it. I'm sorry. Is it happening again now? This is 80 years later.
We're
Yeah,
waiting
it's gonna
for
happen.
it.
We're somewhere. Everybody thinks we're somewhere in here.
You know, I can't see your cursor. It disappears in the white.
Oh, okay. Sorry.
But
That's
each day you can get what its magnitude is at spaceweather.com.
Oh, okay. Okay.
So it'll retrace this same path.
No, a similar
one.
A similar one. Okay. And there's no way any of you guys can get in on this and watch it happening with your
Sure.
scopes?
Sure, if you want to spend the time, just like Chuck said, just track it on spaceweather.com.
Yeah, and Ronnie up at Refugio the other night, it was visible up at the top of the sky. It was right there. And
But
The
only by
constellation.
yeah, it's a constellation called Corona Borealis.
Okay, they're
And-
visible only through a scope, right?
No,
That star is visible only through a scope at this point.
yeah.
Okay, so is there a good chance that by 10 o'clock on a second Saturday night, we might be able to see it at the museum?
I wouldn't
Yes.
call it a good chance, but there's a chance.
He didn't say good, he said chance. There is a
Yeah.
chance.
Well, how do you guys how do you guys that set up your scope for the party decide who's going to do what? What if everybody wanted to be on Saturn? Or
That
Tuesday?
happens.
Does that
I
happen?
used to give out a little pamphlet to people at the beginning of the star party saying these are things that are good to look at this star party, and it would give a finder chart and a little blurb, and I would say, okay, what do you want to look at? And I'd hand it out to people, but everybody would go to something spectacular like Saturn. So I finally gave up on that and just say whatever you want to show, whatever you enjoy.
The other night at Refugio, Ron, I had at least 10 targets that I went to. So
In
I'm
fact-
all over the place with my scope. I go crazy, and it's kind of better to just pick one and stay there. But there was just Refugio. There's just too much to see. It's the temptation is too much for me.
Yeah. It's a beautiful sky there in general.
Have you ever set up and nobody came?
No?
That's never happened. The campers are all up roasting marshmallows at 8 o'clock, 9 o'clock.
Well,
at
we had 100,
117. Well, wait, I'm mixing up
126?
Kachuma.
126, I believe.
Let me see. It's right here in my logbook. The last Refugio, 156.
Oh, 156. Wow. But it was pretty busy, Ronnie. And there are times when the kids got to go to bed. And so the parents will take the kids and it'll be empty for just a bit. And then after that, it may get busy again.
And then
Yeah,
you
they go back to their campsites and they tell their neighbors, and more people come out. Plus, the
Yeah.
rangers go around and announce it, and there are flyers put up on the bulletin boards that it's going to happen, that we have a star party.
Well, do they let you stay much later than 10?
Sometimes.
They can.
Jerry,
We-
are you back? Are you with us?
Yeah.
Speaking of the propaganda, the paperwork Chuck was just talking about, you're going to have to find that email and okay. I think we got the three of us that voted to pay for a bunch of the stuff we
Oh.
give away at Star Parties.
Yeah, Staples was going out of, they're closing in the big box, and that's where we got our copies made because they gave us a great deal.
Right?
And since they're closing, they had half off on everything, and so they had half price for copies. So I got like 1,200 copies of stuff
For the
that
price
doesn't
of
change.
600.
Stuff that doesn't change, not dated. It's not tonight's
Right.
star.
It's stuff that's good all year round. The handouts, like the planets to scale, stuff that beats my printer to death. And so yeah, it was like $500 for 1,200 copies, which is a pretty decent deal for color double-sided.
The other members of the board okayed it without you, Jerry. Sorry.
Well, I don't care whether I'm reimbursed or not. I mean, it was good to have it.
I sign anything your wife puts in front of me, so it's tell her.
Well, I've decided, I don't know if to run this by you or not, but I'm going to pay Alex Filipenko in mid-October the 150 that he got paid last year, and he cashed the check. So just so you'll know, whether you guys reimburse me for it or not depends, but I'm going to pay him.
Okay.
I think we will. It's a good cause.
I wasn't going to bring it up at the meeting, but just in case. Okay, let's go to the moon. To the moon, Alice.
I put this on there. It came up on my Facebook page from Damian Peach.
Oh,
It's a beautiful photograph.
He
He's
does
really
great
good.
stuff.
Yeah.
Look at that one ridge up there in the upper right. It's just like a razor. Higher up, right in there. Yeah.
Yeah. Now this is, I think it's this thing. When I first built my first 6-inch f8 telescope, and I got all the parts from Edmund Scientific in the late 50s, and they had some books by Brown about what to look at and what to see. And one of them showed this bay on the moon, and it called this the Maiden's Head, because at this light, if your scope was not as clear as this, which mine wasn't, this looked like a face and this looked like flowing hair from a maiden.
Oh yeah, I see that.
So, and at a certain phase, you get that effect visually.
Jerry, this is an incredible image.
Yeah,
Oh,
it is.
it's fantastic. Look at that little tiny row of multiple craters there.
But that's the Bay of Rainbows,
Yeah.
Yes.
even though there's no colors necessarily involved.
Oh, there's lots of color here.
Well, they're not in bands, but that's fine. Is it half of a long depleted crater that got smoothed over with Amari?
Yeah, it got flooded by molten lava when
Okay.
whatever made this mare out here hit. Then a large part of it, this part probably sank too, and then the molten lava came up and filled it all in and was flat. And you can see that there's no reed except for this guy who's causing my talk to go astray. There's no major craters on it, so it was a fairly recent event compared to when these craters were made.
I've always wondered this, Jerry. This looks like it's very, very smooth, but down on the surface, it's not that smooth.
No, it's rolling hills kind of thing.
Okay.
And
It'd be
occasional
like
boulders
hills
smashed
flying.
out by other impacts.
Yeah.
Boy, this is some image though. The color he got.
Yeah.
Well,
Yeah, excellent processing.
this is the sort of areas where they landed, I guess, all of the Apollo missions, when you think.
I don't think anyone landed in Marcrizio.
No, but they didn't land in those rocky hills either. Or they didn't try
No.
for a crater. At least I don't think they did. There were some
Nope.
rolling hills. They drove that little car around
Yeah.
and knocked a golf ball at one point. Guess we lost our fact checker. Took a phone call for the cat.
Well, now we can dump a lot of data because he's not going to correct me.
Okay.
So
Yeah.
this is the constellation of Virgo. And we're all familiar with that. Coma Berenices up here, Buddha's Leo. And down here is the Alpha Virginis Spica. It's a bright star. It's the 12th brightest star in the sky.
Huh.
And this is the spectra. It is a double binary, spectroscopic binary. You can't resolve the two stars. They're too close together. They're only 1/10 of an AU apart.
Is that right?
And that's pretty close.
That's 9 million miles.
About 10, yeah. And you see, these are the spectra of the two stars. And you see the point down here is shifted from the point down here. That's the Doppler shift. So one of them is coming, if it's going this way, this one is coming toward us. No, that's the other way around. This one is going away from us because it's red shifted. And this one is coming toward us because it's blue shifted. So that's how you can tell it's a binary. You get two separate spectra and they shift in coordination with each other. But the star is not in the same, it's not rotating each other. They're not rotating each other in the same plane we're looking at it. So this is what it looks like at different phases. This is when the black one is ahead of it, or behind it, I mean, and the yellow one is ahead of it. This one is in front and this one is not, but they are offset. Here, they're beside each other. So this one is farther in back. This one is more close in front, and this is farther and back on the other side. So as they go around, they go in a plane that's tilted with respect to us. You get that?
Is the yellow the other star?
The
Yes.
yellow is one star, the black is the other star.
Okay, and the black is the one we care about, and it actually shrinks in size.
No, it
No.
just goes far. This is not to scale, it's exaggerated to
Oh,
show that it is going behind. The smaller one is farther away. When black is small, it's farther away.
oh, I see. And they're orbiting. They're binary.
They orbit each other. They orbit a common, we learned the word, a barycenter. They're both rotating around a point that I would place probably about here.
Right, the barycenter. That's right.
Yeah. And they probably don't look, these are round representations. These are obviously not photographs. These are from a model. And the text says that these are most likely egg-shaped. That is, they're most likely prolate on this side and oblate on this side. That is, flatter on this side, but more pointed on this side. So they look like two eggs pointing at each other all the time.
But
And
nobody.
the color doesn't show well on this display here.
Oh,
And
okay.
don't bother changing it because it won't make much difference. But on the sheet, on the handout you sent, you can see there's gradations in color on the yellow star. And I'm wondering if that's because the other one is close enough that its radiation and winds affect the brightness of the bigger one that's shown in yellow.
Yeah, it's always got this darker color. There it's facing it, here it's facing it.
Yeah.
Here it's kind of on the wrong side, but here it's facing it. Yeah.
And it's not limb darkening, but it's some
No.
other effect.
Yeah.
And we're not looking at another T corona borealis. Not one is sucking
No.
off the other, right?
No,
That's correct.
these are not swapping material. There's no indication of a bridge between them.
What are the odds there's an exoplanet or two around one or both? Can you have exoplanets orbiting two stars?
Yes, if the exoplanets are far enough out, since these are like 1/10 of an AU, which is what, it's closer than Mercury. So you could have something out farther like a Mars or a Jupiter that would not care that the two things are rotating around each other. It would have little waves in its orbit, but it would form a semi-stable orbit that would be stable for a long time.
So you'd have a planet like in Star Wars, right? With the two suns in the sky.
That would be a
Yes.
good candidate for Tatooine.
Okay, got it. Well, I've never seen spectrographs that look like this. They're always the other direction. They're pointing up.
Oh, well, I can turn it over if you like.
It just
Isn't
depends
that
on
how
whether
it
you're
is?
looking at absorption or emission, Ronnie.
Yeah,
That's how something that's speaking means you see it.
yeah.
There's that element or compound in the atmosphere.
But in this case, this is where you're losing it.
Is that right?
This is absorption.
And every one of those dips and cones and points stands for a different part of the list of elements, the table.
Well, multiple dips could belong to one element, but yeah, in effect, they're fingerprints of elements.
Remember, when you look at the spectra of our sun, it's a red uniform, blue, yellow, red, and then there's black lines all across it because there are no emission lines in the sun. The ball of the sun is a black body emitter. It's not a line emitter. So it goes by the black body equation. What is that? I forget what it's called. But the Planck radiation. But the atmosphere, before it gets away from the star, this uniform black body emission gets absorbed by a lot of nuclei that have escaped from the sun, along with a lot of electrons that have escaped from the sun. And they found each other and they've formed atoms. And the electrons are now getting excited by the light that's coming down, and they're absorbing the light coming up from beneath them. And so in a sun-like star, in any star, you're going to see absorption lines from the star, not emission lines, because the star doesn't produce emission lines. It emits in a black body curve.
Ronnie, I'm going to make you feel great here. Whenever Jerry talks about this stuff, or Chuck, or Tom, they get it. I don't.
Well, this much I get. In the sun or in the star, you don't have atoms. You just have crazy protons and electrons
And
going
neutrons.
crazy. So when it gets to the edge, the corona, if you will, they form into atoms, and that's what these lines represent.
Well, yeah, the upper atmosphere of the sun, but not necessarily the corona. The corona is really hot.
Yeah. And no one knows really why it's so hot. But yes, it's millions of degrees, but it's thin. It's very thin compared to the body of the sun.
Well, certainly upper elements on the periodic table would never be shown unless the damn thing's ready to blow and it's close to making iron.
No. That gets made in the core. You wouldn't see that.
Yeah.
So all we're looking at is the lower elements like nitrogen, oxygen.
All you're looking at here is the atmosphere of the star as absorption lines. There might be an iron atom in there or something, an iron nucleus might have got out. There he goes, and an electron will follow him and join up, and then you get an absorption line.
Huh.
Yeah, we see calcium and iron and other things in the outer atmosphere of the sun.
Yeah.
And that's not what we're looking at here.
Yes.
Yeah.
Oh, it is.
That's what you see. And when you see a spectrum of a star, you only see emission or absorption lines, because the body of the star is a black body emitter.
It's emitting a continuous spectrum, a rainbow.
Right.
So the two big dips, the points down, a third of the way across, represent something going back in. What
No, it's an atom it's some kind of element in the atmosphere of the star.
Yeah. And there's a lot of it.
I'm
we don't know
almost
what it
getting
is?
part of this.
Yeah, we know what it is, but it just doesn't say in this particular
Yes. Every one of these lines is understood.
And these are the two stars involved. They're that close.
Those are the two. This is one star here, and
Right.
this is the other. I think this is the mass of the star.
Well,
0.841, and this is 0.152.
Spica is a blue star. It's going to be more than that.
Okay.
Do most stars have a line that looks like this?
Most stars, all stars have absorption lines of some kind. It depends on what they're throwing off. You know, our sun is throwing off a lot of hydrogen, and so we have a real bright line or big black dip at the 600 nanometers where the hydrogen alpha is.
But the hydrogen has become atoms by that time, as it's got electrons around
Yeah,
it,
it's got
rather than just,
it's got disciples with it.
okay.
Yeah.
Red dwarfs
And different stars will have different absorption spectra. And that's how they first started classifying them. And they gave them they just started saying, this is type A, this is B, C, D, E, F. And then when they actually figured out the Hertzsprung-Russell diagram type classification of stars, that's why you get the O, B, A, G, F, K, M. Because they said, oh, wait a minute, if you look at the mass of the star, the O stars that we classified by their spectrum were actually the bright ones, and then B and A.
I know we've run out of time, but to refer to Jerry's speech, the same spectrograph of an exoplanet's atmosphere would probably be different, much different, right?
It would be emission lines and absorption lines.
No
It'd be
absorption.
much more complex. There are atoms on planets.
Yeah.
Well, you did good. Will you do it again if we all gather around you on Monday?
Sure.
All right, then let's do it. This is a habit of ours, and there's no cure for it. It's an addiction. We'll do number 287 next week if you'll join us on the Astro Hour, everybody. And we'll see you in 3 weeks at our general meeting. And doggone, go out to Refugio or to every Sunday you're watching the sun, right, guys?
Mhm.
Absolutely.
Anything happening real quick we could talk about in the next week?
Tomorrow night is Telescope Tuesday, and Friday is Westmont.
Westmont.
All right.
Okay.
Well, thank you for joining us, and thank you, and
Thanks.